looks weird. Sorry, 1 second. There we go. Cool. All right. So, welcome back, everyone. Hi, my name's Jake. I'm a community manager, and I'm here to talk to you guys about an introduction to domains and what's up.
Your projection is wrong. It's okay. Just leave it this
way.
Okay.
Okay. It's better. Never mind. Here to talk about domains and hacking, and honestly, this is one of my favorite topics. Probably my second favorite after like exploitation, privilege escalation, that sort of thing. But excited to share with you guys. So for those of you who have stuck with us over the course of the semester, we've covered a lot of different layers to security in the security model, protecting individual machines, network protections, architecture protections, that sort of thing. And so if you are a hacker and you have spent you've thrown up your hoodie, you've got the cap on backwards, and you've got your shades or your balaclava, and you've been hacking for hours on end, and you finally broke into that machine, and it turns out to be it's Janice from accounting, and she has nothing important on her computer. Dang. Well, there are directions to start going from there. And so this is highly relevant to the penetration testing practice in the actual industry. But yeah. On with it. Okay, so yeah, we're CSG. Get in touch with us. We have a mailing list. If you haven't signed in to the little sign-in sheet, please do at some point. It helps us a lot. The more people that sign in, the more pizza we can feed you guys every week. So yeah, that's good. We have a website, csg.utdallas.edu. We post videos, these slides, and information about events there. Good to keep track of that to see what's going on. And if you're not part of UTD's ECS Slack channel, I highly recommend you join, because we have the best channel, which is the CSG channel, and very easy to get in touch with security-minded individuals through this Slack channel, and generally fairly active. And if you have like questions or you have a cool topic to present, and you mention something in that Slack, it's very likely the easiest way to get some of the officers here's attention. And if you need to contact us, you can email us at utdcsg@gmail.com. Announcements. Okay, so like I've been saying for the last couple of weeks, we have started this new thing. Every Thursday at 4 p.m. we will have our lab open to visitors, so you can just come chill, hang out. If you want to talk some cool security stuff, officers are always down to ramble about cool security stuff. On top of that, for the last couple of weeks, I've personally been hosting some demos that have to do primarily with penetration testing, using virtual machines hosted by Hack the Box. I got a decent little crowd last week. My plan going forward from here is to, rather than coming in and showing people Hack the Box, I would really love it if I could get some people who are interested in that sort of thing to come visit, and we could work through some puzzles and problems together. I think that would be really awesome. And you guys are now very informed about State Farm CTF.
That date should be the 9th, by the way.
Whoops. That should be the 9th, by the way.
We'll change that.
Yeah.
It's just this Friday is the due date.
Okay, so now we get to actually talk about domains and hacking. Well, here's the thing. You know how if you want to learn how to hack something, or if you see somebody hack something and you don't know how that thing works, it sort of seems like black magic. It's kind of especially true, I think, with domains. So we're going to try the best we can to give a very full and decent explanation of what exactly a domain is and how it works, and then go from there and explain how to attack it. So yeah, and hopefully if we have time, I'm going to demo a few short demos toward the end. So I'm going to let Ian take over now.
Thank you. All right, so intro to it. Why do domains exist? If you have done any sort of networking, you will realize most of the time that it's fairly simple networks that you're messing with, because you'll just create a few hosts or something of that sort and see how they work together. In the real world, out with corporations and companies and all kinds of organizations, they actually have something that is a lot more in detail. You want it to kind of mimic the real life scenario that you have. So for example, with a company, you're not just going to have one group of users or something of that sort. You're going to have a marketing team. You're going to have legal. Let's see, what else? IT. I mean, just a variety of different areas that a person can work in, and you don't want them all to have the same privileges. So it is important to have something that kind of mimics that almost architecture, that layout of the organization, and to be able to assign privileges in accordance with that. And also, when you have something that is so complex, you're not going to be able to configure everything manually. It's just too much work. So you need a centralized way to be able to do that. And that is precisely where domains come in. So domains and their contents, domains are just kind of complicated networks, is a kind of a good way to look at it. Within a domain, typically you will have the domain controllers, which, I mean, you need a domain controller, at least one, for a domain, because that is what controls everything. So that's usually its own separate machine within there, and that contains a database to store important information like user records and passwords and all of the configuration data, how security should be enforced, and even networking throughout the domain should be enforced. So that is highly important to have the domain controller. Also, domain name service, DNS, is important for locating those domain controllers and any other systems that you may have within there. For example, skipping down the slides a little bit, like mail or file servers or printers or just any sort of hosts within the network, usually will have a domain name that they can be accessed by. And so that is important to have the DNS. Additionally, you need user authentication. So that is for, that's the privileges, who is able to access what within the network. And specifically looking at Kerberos and NTLM, which is the NT-LAN manager, I believe is what that stands for. Nice little Windows acronym. And those are basically they're authentication protocols in order for a user to prove to a server or some system within the domain that they are who they say they are, and after authenticating, being able to check to make sure they have the correct privileges to do certain things within those systems. So Active Directory is typically the domains you will see, like the type of domains you will see within large companies. I mean, Microsoft market penetration is, it's just the best currently, because it's just a lot of people are familiar with Microsoft and Windows, and so it's a familiar system that they can enforce throughout the organization and have something that is fairly consistent. So Active Directory is Microsoft's solution to Windows domains, and that includes specific tools, which are LDAP, Lightweight Directory Access Protocol. So that stores kind of the records of the users and the systems. Then there is Kerberos, which is the user/service authentication, and then NTLM, which is kind of secondary user authentication most of the time. It can be used primarily, or it can be used as a primary source of authentication, but generally Active Directory prefers using Kerberos, and I will get into those a little bit further. So LDAP is an open protocol. It's got a specific format of information about a specific user or system or something of that sort. And if you are looking for a particular service or a user within Active Directory, LDAP is typically the way that you will go to do that. Of course, you need the correct privileges to view certain users. It's important to not allow everyone access to everyone's information, so there will be a little bit of limiting based on privileges there, but it is a centralized way to look up the users and hosts and services throughout the domain. It has typical operations, which are add, delete, and modify. Additionally, you can search for specific users, and you can compare to see if the specific entry or user or system is within the LDAP directory. So this is an LDAP command. So we've got multiple fields here that you can see. We have the domain name with a user ID, the OU, which stands for organizational unit. This is important because this will be like your marketing or legal. It's the department that you work within usually. And then additionally you have your, oh my goodness, what does that stand for? It's not domain controller, which you will see DC a lot, and that stands for domain controller, but this is the, oh, it's right there on the tip of my tongue. I apologize. Domain component, there we go. I knew it was one of those words that was not quite what I was thinking. Okay, and then you also have the change type. So for an add, you're going to be adding a new user or a new entry into LDAP. Then you've got the object classes. This is used as kind of like a tree hierarchy. So you'd have the top or the root object class, and then from there you have other object classes down from it. So for example, you can have person and then org person or INET organizational person. There's typical standards for this, but it's just kind of a hierarchy of the groups or roles that you can be in. And then once again it reiterates the UID, and then you have CN, which is common name. You can also have the common name along with a surname. You can include emails, phone numbers, even passwords, which is not recommended, but it is possible. And then for this one, I just decided to make it Leet Hacker because, that's a good common name. So there are within Windows or within within Windows, there's a concept of groups, and even beyond just Windows, if you're familiar with Linux, you can usually put users within a specific group. And it seems like with the organizational units would be kind of the same as a group or using group policy, which we've discussed a little bit previously. You can put these users within a group and then give them specific permissions. However, they do differ usually in the way that they are used. For groups, they are typically done, an object has certain permissions, whereas with an organizational unit, you can actually kind of split up the groups, and you can do it based on specific people or subsets of the group in order to give certain permissions. For example, you may have like an administrators group that has special permissions throughout the network or on certain resources within the network. However, you may want to delegate certain authorities to a different person. For example, with my example, the marketing manager perhaps you want to give them the ability to reset passwords or something similar to that. You don't want to have to create another group just for that person, so you can actually give those privileges to the specific organizational unit that they are within, and then they are able to exercise those privileges as a higher privilege user within that specific organizational unit, without having to create a group overall for the network or a new group overall to manage that specific privilege. So on to Kerberos. This is user authentication. It was created by MIT in the 1980s, late 1980s. It is important because it is highly used. I mean, it's the main source of user authentication and service authentication within Active Directory. The reason why it is both is I'll go into the details a little bit more, but basically you've got it where a user and the service that they're trying to access have a special key or a special token in order to verify that they are themselves. And so when messages are being sent around, if they can't decrypt the message, then obviously they are not who they say they are. So you can, both the user and the service will be verified by a centralized source within Active Directory. A key component of Kerberos is the concept of tickets. What tickets are is they are special cryptographic, how do I describe it? Tokens. So they're almost like tokens that can be encrypted or they are encrypted, and then they can be decrypted based on special keys within the owned by the different users and systems in order to access certain information and to give the privileges necessary. So there's a lot of text on this diagram. I'm not going to go step by step with the text. I'm going to kind of summarize it, but I wanted to include this there because I thought this was a good diagram of it. And so if you're interested, you can go back later and kind of look through this and get a fairly good idea. There's lots of resources online for learning Kerberos, and it's very useful if you have any intent in working with Active Directory, because Active Directory is highly used, and this is user auth for it. So basically the way that it works is the user says, okay, I want to access a specific service, but before I do that, I need to authenticate to the key distribution center. So that is this over here. And it sends its user ID. Within the key distribution center, it should already have something like a password or something that can be used as kind of the key of the user. So the user sends its user ID. The key distribution center typically will like hash a password or something of that sort for the user. Then it uses that key, the hash, to create a new key with combined with the key of the ticket granting service. So this is kind of who the user will talk to in order to get permission to access a specific service. So once the key distribution center, and specifically the authentication server component of the key distribution center, hashes that password, creates the client/ticket granting server session key. So this is within this specific instance of the user wanting to access a particular service. It will generate this key that is different from other ones, and this is good because if someone intercepts this once that particular ticket expires, they can't reuse that, and additionally, they aren't going to be able to use the tickets for services that they are not authenticated for. So the key distribution center creates this session key, sends it back to the user along with a ticket granting ticket, which is something that it can provide to the other component of the key distribution center, the ticket granting server, and that specific ticket granting ticket is encrypted with the ticket granting server's key, private key, or password, or whatever it is. And so only it should be able to decrypt it. Only the ticket granting server should be able to decrypt the ticket granting ticket. So it sends these back to the user. The user sends that ticket granting ticket to the ticket granting server and also provides a service ID, which are unique within the Active Directory. And it says, okay, I want to access this particular file share. And the ticket granting server says, okay, let me decrypt this. It makes sure that the user ID is correct and that the user has the correct permissions to be able to access the server or the service they're requesting. Then it creates a new session key, and this will be between using the client's private key or password and the server that's providing the specific service it's asking for, its private key. So new session key sends that back to the user along with a new ticket to send to the service, that after the user receives both of those, it can send the message to the server with it that can only be decrypted by the server, and it can basically authenticate to the server. And because both were authenticated from the key distribution center, both can be trusted with each other, and they now have a way to speak privately through their session keys. I know that's a lot of information. It can be a little difficult to get the first time around. So I would highly recommend looking over it again. Yes?
So when the user sends information to the service, is that a ticket?
So when the user sends authentication to the service?
Not authentication, when they try to access, or when they try to
Mm-hmm.
is that considered a ticket when you pass that information?
Yeah, essentially you got two different types of tickets. So you got that centralized server, the ticket granting server, that gives you the ticket granting ticket. That's one type of ticket, and you present that to the server that has the service you actually want to use, and then from there you're going to get a token, your service ticket, basically.
Mm-hmm. Yeah.
But
So
is
it.
the ticket itself the message, or is you pass the message with the ticket?
So the ticket is a message for the service that is provided to the user to provide to the service. And so it uses that. And actually within the diagram, you can see it here. It's the service ticket. And then you've also got a session key going over there. And it is, it should only be able to be decrypted by the service. And that includes information about the user to basically say, yes, they're verified to be authenticated in who they are, and that they are allowed to access your service. So, yeah. It's a good question, though. Thank you. All right. Oops. All right. So on to NTLM, and I will let Jake take this.
Sorry, stream people. Okay, so your ultimate end with that with Kerberos was you have that central server that you get the ticket granting ticket from, and then the ultimate the token that you end up with is that service ticket. And what that's going to let you do is authenticate with this particular server for this amount of time. So it's a relatively narrow attack surface that you're left with. Now, in contrast, NTLM is a little bit different. And there's a reason that we prefer Kerberos over NTLM. So it's sort of similar in that you're authenticating against a central server in the domain controller. And there's they do some cryptographic stuff. There's challenge response, which essentially means, hey, can you decrypt this? Tell me what it says, or sort of. And if you have entered you have correct credentials, you can use the hash of your credentials to decrypt it, and you can authenticate that way without sending clear text credentials over the wire. So from that perspective, it seems kind of handy. And from there, you end up with an NTLM hash, and that is what you use to authenticate with anybody else in the domain. Which means, again, you're not sending any clear text credentials over the wire, which sounds good. This is also good for providing single sign-on, because you don't want to make your users authenticate every time they talk to a different person on the domain. They don't like that. But, so those hashes, those NTLM hashes, those are what you use to authenticate with everybody, and they get stored locally on every machine. Which means that if somebody has access to those hashes, they essentially have all of the authentication that they need. Which, that's fine. Just don't let your users look at that stuff. Don't give them local admin privileges. But privilege escalation is a thing, so that's not good enough. How much time do we have? Okay, so we're running a little bit late. I apologize for that fact. I'm going to try to... Okay, so I would normally go into detail about some attacks and some demos. But since I'm running a little bit late, I think since we've just sort of covered the ground basis of these are the technologies, this is how they work, we're going to come back not next week, but after spring break, and I'm going to demo. Right now I have a virtual domain set up with that authenticates with NTLM. So I was going to show you a patch the hash attack, which essentially was going to take those NTLM hashes and authenticate into places that you're not supposed to be able to. But I'm thinking I might save that for next week, and also use the time between now and next meeting in order to set up some more demos like Kerberos, so I can demonstrate pass the ticket, how it's similar to pass the hash, what its limitations are, and how you can still, though it's more difficult, break some of the security in Kerberos. But yeah, so. Yeah, well, that's all I'm going to do for this week. You guys, if you have any questions, also I probably should have been looking at you guys might have been asking questions in the thing, and I didn't look at it. My bad. Hacking indeed. I've never hacked. Where should I start? Okay, somebody asks, if I have never hacked, where should I start? Are there certain languages I should know? Do I need to get Linux, or should I stick with Unix? Your boy needs guidance. All right, my boy. I mean, Linux versus Unix? I actually haven't used Unix, so I just sort of assumed if you use...
If you have a lot of money, then sure, get Unix.
Like...
Linux is free.
Yeah. I suppose Unix would also work. Or should I, certain languages you should know, in my personal opinion, there's a lot I could talk about this, and I'm actually going to not go too far in depth because I'm running late on time, but I would say that a scripting language is very handy in this sort of field in order to be able to very quickly whip up tools.
Python.
Yes.
A lot of people love
I like Python.
Learn C and assembly. And if you really want to do fun stuff.
What's assembly?
It is heaven and hell. It is
the Matrix.
Level language that humans can reasonably understand, and it's basically the bits that your computer understands translated to bytes, which are collections of bits translated to specific instructions that your processor can run. And it is specifically important for if you're trying to break applications and systems at the lowest level possible.
If you're OG. Anyways, so I highly encourage you guys to come and chill with us in our lab tomorrow and all the other Thursdays at 4 p.m. Again, room number is 4.619 in ECS South. Hopefully I'll be able to see some of you guys there and I'll hack with you. And
if you have any friends that would like to do a CTF or you think would enjoy doing a CTF, State Farm CTF is a great one to do.
And it'll be first.
all right, well, thanks guys. See you guys later, and we'll be around if you have questions.